In this episode, we work to find the height of the point that has traveled pi over 4 radians counterclockwise around the circle. This will then give us a point on our graph at pi over 4, comma, the unknown height.
So that's 1/2 of this. Yeah, it would. I feel like almost exactly right there. Because pi over 4. Oh, I'm still with the highlighter. Pi over 4 is 1/2 of pi over 2. And then, so that means that it would be pi over 4, comma 1/2 radian.
Does it have to be 1/2? How do you know that it's 1/2?
How do we know that y is 1/2? Because if we travel pi over 4 on the circle, it's going to be half of pi over 2. So it's going to be, say this is the half point. We're measuring the height right here,
Right.
which should be exactly half of this line right here. I know it doesn't look like that on my dot, but
Is there a way that you can calculate that it's equal to 1/2?
Well, so if we're saying that the height of pi over 2 is 1 radian, 1/2 of pi over 2 is pi over 4, so then 1/2 of 1 is 1/2. So using that same conversion factor, we can say that pi over 4 is 1/2, has a height of 1/2 radian.
Okay. So just to repeat, you said that if you take pi over 2 and divide it by 2, you would get pi over 4. So you did the same thing for 1 radian. You divided that by 2 to get 1/2.
Yes.
Okay. What if I tried to apply that for 1/2, comma 1 to pi, comma 0? I could multiply pi over 2 by 2 to get pi. But if I multiply 2 by 1, I don't get 0.
To find the height of the point on the circle, we can draw a triangle by drawing a line that connects our point to the center of the circle.
Do we know any of the values on this triangle?
Yes, this is, sorry. This is a triangle. We know this one, right? So this is the radius. This is equal to 1.
How do you know it's 1?
Because this line that this little bracket is representing is equal to 1, which is the midpoint to the furthest point of the circle, or to the outside of the circle, is equal to 1. So this to the outside of the circle also has to equal to 1.
Excellent.
Would we have to use Pythagorean Theorem to reverse it and find it? So we've got the hypotenuse, right? So that's C. So 1 squared equals B squared and then A squared, right? But we are trying, this is A, this is B. Okay. These are the same length.
How do you know?
So if you're, how do I say this? We're assuming it's forming a right triangle, right?
Okay, yeah.
Because we've got...
We can assume this is forming a right triangle because the side we are attempting to solve for is the vertical line extending from the axes to our point, because it is the height of our point. This means we can use our Pythagorean theorem. Recall, the Pythagorean theorem says that a right triangle with sides A, B, and C will satisfy the equation a squared plus b squared equals c squared. As we've already said, our c is 1 because it is the radius, and in radians, a radius is equivalent to 1 radian. Then, we can actually say a is equal to b. But how? Because pi over 4 is halfway along the point's journey from its starting position to the top of the circle at pi over 2, we know that the angle formed by our line is pi over 4. We can use this to find the missing angle of our triangle. Recall the fact that the sum of the angles of a triangle is equal to pi. This means that the missing angle satisfies the equation pi over 2 plus pi over 4 plus x is equal to pi. Solving for x tells us that the missing angle is pi over 4. Thus, we have a triangle with congruent angles, meaning their side lengths are congruent. Finally, we can use this information to solve for the side length.
Okay. Now how can we solve for a?
Divide by 2 first. Right? And then you square root it.
Did you just square root it first?
It doesn't matter. But you can't square root because you don't have root 2. So then you get a squared equals, well, 1 squared is 1, so you get 1/2. Then you square root both sides. Then you can rationalize.
Boom, perfect.
And then you get a equals rad 2 over 2.
Okay.
So
Good job.
what does this mean our coordinate is?
It means our coordinate is pi over 4, comma, radical 2 over 2.
That's exactly right.
Yay.
Can we get that on here?
It's this point.
Great. Really, really good. Nicely done.